This is a continuation of the Chapter 6 review, beginning with Problem 9. Tell whether the orthocenter of the triangle with the given vertices is inside, on, or outside the triangle, then find the coordinates of the orthocenter. So, to begin with, let's go ahead and bring up that triangle. So here we have triangle GHJ 165631. And for the first part of the problem, we have to determine if the orthocenter is inside, outside, or on the triangle. Now, in this case, orthocenter is the point of concurrency of the altitudes of the triangle. An altitude is a point from a vertex perpendicular to the opposite side. From a vertex perpendicular, from a vertex perpendicular. So, if this were an obtuse triangle, then the orthocenter would be outside the triangle. If it was a right triangle, it would be on the triangle, and an acute triangle, it's inside. So we can clearly see that this angle, had this segment been over here, would have been a right angle. And so this angle is clearly less than 90 degrees, which this one is as well. And so this one is also less than 90. So this is an acute triangle here. So we know that the point is going to be inside. So that's our first piece for number 9. Okay. Now to find the orthocenter, that's the real tricky part. So we're going to need to find a line from this point perpendicular to that side. Well, this one is a fairly straightforward one because we can see that this is horizontal, so the vertical piece is going to go along the line x equals 3. So that's going to be our first one, and we can see that the point is going to lie somewhere on this line. So let's go ahead and draw that in, and let's get a different color. So we will go from here up. Okay, so we know that our orthocenter is going to be somewhere along this line. Now we need to find a line either along this line here or this line here, perpendicular to this segment or to this one, to find the actual orthocenter. So because G has smaller numbers, I'm going to use this point just for convenience, and I want to find the equation of the line through this point perpendicular to JH. So we're going to have to find the slope of JH. So that's our first part. So let's go over here, and slope is difference of the y's, so 6 minus 1 over the difference of the x's, 5 minus 3, which gives us 5 over 2. So the slope of this line is 5/2. Now, the slope of a line perpendicular to this is going to be the negative reciprocal, so my target slope is going to equal negative 2/5. Not terribly pretty. Alright, now we need the equation of the line through this point with this slope. So let's use this and the point slope form. So y minus y1 is 6 equals m negative 2/5 x minus x1, which is 1. So let's working this out. Y minus 6 equals negative 2/5 x plus 2/5, and then y equals negative 2/5 x plus 2/5 plus 6. Now we've got to get that 6 in terms of fifths. So 6 over 1 times 5 over 5 gives us 6 times 5 is 30 fifths. And so this gives us y equals negative 2 fifths x plus 2 fifths plus 30 fifths, which is y equals negative 2 fifths x plus 32 fifths. Very, very ugly. Now, to find the point of concurrency between this line, which is y equals negative 2 fifths x plus 32 fifths, which is going to go through there, we need to find out where the y coordinate of this line is on this line. So x is going to be equal to negative 3 along this line. So we know that we have to set x equal to 3. Again, because this line is going to go through here, where these two lines intersect, the x coordinate has to be 3, because the point of intersection, the point of concurrency, has to be along the line x equals 3. So we're going to set x equal to 3 in this equation and find the y value. So y equals negative 2 fifths times 3 plus 32 fifths, which is y equals negative 6 fifths plus 32 fifths. So y equals 26 fifths. That means that the coordinate of our orthocenter is going to be 3/26 fifths. If you actually work that out on a calculator, that's, if we wanted to use decimals, that would be 3/5.2, which would make our orthocenter somewhere right around here, which would make our other segment would have been just about like that. And there you have it. Now on to problem 10.